feel the vibe.
What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we continue our work with basic sequences in series. When we left off previously, we had taken a look at partial sums and summation notation. Today, we're going to expand on that topic in this video with summation properties. So there are three properties that we have for summations and summation notations. Essentially, what each of these three properties allow us to do is to rewrite or work with summations in different ways. So for instance, if I have for any constant c is a constant meaning it's a number that's unchanging. If I have a summation of beginning with 1 going to n of c, this can be done as c times n. So let me give you a numeric example for that. If I had the summation of, let's say, k equals 1 to n of 4, or let's say k equals 1 to 3 of 4, we could do this as a summation where we do 3 plus, or sorry, not 3, the terms would be 4 here because our formula for each term is 4. So this would be, the first term would be 4, second term would be 4, and the fourth term would be 4. So we could either do 4 times 4, or 4 plus 4 plus 4, excuse me, to get 12, or we could take n, which is the upper bound, 3, times the term or the element 4, 3 times 4, which is 12. So just depending on how we look at that summation, we could do the addition of the terms, or we can multiply the element times the upper bound or upper limit to find the value. The second property we have here is if we have a constant multiplied to a expression for the value of a term. So for instance, here we have c times a to a sub x. We could write this as c times the summation of a sub x. So for example, here, let's say I had the summation of k equals 1 to, let's go to 3 again. And now let's say I have 2 times, let's say the element is going to be n over 3. What I could do, instead of taking 2 times n over 3, I could do 2 times the summation of k equals 1 to 3 of n over 3. And so how I would evaluate this would be taking 2 times 1 over 3, 2 times 1 over 3 plus 2 over 3 plus 3 over 3. And in this instance, I would get, if I added inside the parentheses, I would get 1 over 3 plus 2 over 3 plus 3 over 3 is 6 over 3 times 2 would be 4. So 6 over 3 would give me 2 times 2 would give me 4. So it's just, instead of doing 2/3 and then 4/3 and then 6/3, I could do 1/3 plus 2/3 plus 3/3 and multiply that all by 2. Just changing the order a little bit there. And so it allows us just some different ways of processing things. So let's take a look at the third one. The third is if I have the addition of 2 elements, I can do the summation of each element at one at a time and then add those together. So for instance, let's say I had, so this is most useful here is if we had maybe, let's say we have a sum of, let's say k equals 1 to 3 of 3x minus 3. Actually, let's say, let me change those numbers there. Let's make this 2x minus 1. So I have multiple terms in there. So I could rewrite this as the summation of from k equals 1 to 3 of 2x minus the summation, oops, how's that written there, of k equals 1 to 3 of 1. And so this would be easier to do. The summation here for 2x would be 2 plus 2 times 2, or 4 would be my second term, plus 6 would be my third term. And then I could do minus the summation from 1 to 3 of 1, going back to our first property, would be 1 times 3, which is 3. And so this would equal here 9. Okay, so this just really gives us different ways to work about completing problems. So let's take a look at an example number 9 here. Number 9 says recompute the summation of 3i plus 2, beginning with the first term as 1 and ending with the fourth term. And this is the problem from number 7 that was talked about in the last video. So we can compare our answer here to number 7. So what I may notice first is I have an addition of 2 terms here. So I can split these up into 2 summations. So I have the summation of I starting at 1 and ending at 4 of 3 times I. And now I can add the summation of 2 starting at 1 and ending at 4. Now, I also may notice that I have the second property here with this first sigma. So I can split this up. I have a constant times the term or the variable here. So I can rewrite this as 3 times the summation from 1 to 4 of I, and then still having the summation of 2 from 1 to 4. Now I can quickly do some summations here. So this 3 would stay there. 3 times the summation of I from 1 to 4 would just be where I is 1, 2, 3, and 4. And then for the second summation here, I have a constant. So I can just do the upper bound times that constant. So 4 times 2. So 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. So I'd have 3 times 10, plus 4 times 2 is 8. 3 times 10 is 30. And I would get 38. So you can compare this here. You can compare this to what we did prior to, let me pull this up, what we did with problem number 7. And we can see that we got 38, but just in a little bit of a different way. And actually, in this instance, what we just completed using the properties may have been a little bit longer of a route to get there, but it gives us essentially some different tools to put into our toolbox to evaluate summations. So here we have some examples of properties of summations that can be used, if needed, to simplify things. As always, thank you guys for tuning in, and I'll